irrational function is a function whose rule can be written in the form f of x equal to some p of x over some q of x, where p and q of x are polynomials and q of x cannot be 0. F of x is undefined for any x values that make q of x equal to 0. Okay, so a lot of these questions you can just pretty much graph and answer. All you really need to know is what is an asymptote and how do you find it. Okay, so let's do an example. Which of the following functions have a graph that does not have an asymptote? Okay, so let me show you visually what an asymptote is. Basically, when you have an irrational function, like, I don't know, let's say 1 over x minus 2, right? Zoom out a bit. So as you can see, if I plug in 2 here, you'll get a 0 in the denominator. So x equals to 2 is the asymptote. See how basically an asymptote is just a value. They cause a division by 0, but the function never actually touches. So it gets infinitely close to the number 2, but never crosses it. See that? It goes on forever to a negative infinity here, and it's never going to get there. Okay. So x equal to 2 is the asymptote. So it approaches it, never gets there. So the question you're going to ask you, what is the asymptote of this function? So all you have to do is set the denominator equal to 0 and solve it, or you can graph it and kind of look at it. Okay. They'll also ask stuff like this, which are the following have an asymptote. So let's find that question. But sometimes they don't, even though they are rational. So let's call this A. So 1 over x squared plus 7 b f of x is equal to 1 over x squared minus 7 c f of x is equal to 2 over x squared. I ran out of space. Let's put d down here. Okay. f of x is equal to 3x plus 1 over x minus 9. So if you see something like this on the homework, you could graph each one and check, or just look at it and say, okay, which one of these will never have a 0 on the bottom? So this guy is pretty obvious, I hope. If I plug in a 0, it turns into a 0 on the bottom. So right away, this is not going to be chosen. So it's not that one. So this one, if I plug in a 9, right? The bottom will be 0. So no. And if you don't see it, what you're supposed to do, let's go ahead and look at the ones we just crossed out. What you're supposed to do is just say, you know what? When is the bottom 0? Well, if I solve for x, x is equal to 0. If I go to the d, if I solve the denominator for 0 by adding the 9 over, that's when the asymptote happens. So this is the asymptote for those functions until you find them. Okay. B would be x squared minus 7 equal to 0. You would move that 7 over. Then you would square root both sides, right? So x is equal to plus or minus root 7. So this has two asymptotes. So the only one that's not going to have a solution is going to be A, because there's nothing that you can square that will become negative and then subtract 7, right? It's never going to happen. Because you see, you guys understand, right? If you square something, it's always positive, no matter what it is. So there is no real number that when you square would become negative 7, right? It's just not going to happen. So this is going to be the one without asymptotes. And if you try to solve it, you would see, right? Set the bottom to 0, subtract both sides. If I try to square root a negative, I'm not able to, right? That's going to be an imaginary number. So there's no real solution. So when you have one that doesn't have a solution, then that's the one that does not have an asymptote. You can also graph them and just look at them, okay? Let's try that next. Okay. And so the first one was A, right? Next one was 1 over x squared minus 7. C was 2 over x squared. Got lazy there. Should probably put my function. And the last one, wait, yeah. The last one was 3x plus 1 over x minus 9. So let's turn them all off. There's too much going on. If you see this guy, there's no x value that it has problems with, right? There's no gap. Although it's never 0, which is why it approaches 0 as a horizontal asymptote, but does not have a vertical. Look at this guy. There's two spots right here It can't be. And that's going to be the square root 7 that we found, which is some decimal. Square root 7 is about 2 point something. Square root of 9 is 3, right? Square root of 4 is 2, so it's somewhere between 2 and 3. So this makes sense. And then the minus version is negative 2.5. So somewhere around there, 2.5 something. Look at this guy. This bottom can't be 0. So yeah, which we already solved for. X will never be 0. Here, X will never be 9. So you can just graph and eyeball it. You can set the denominator to 0 and find out. You can do it in a couple of different ways. Of this rational function. G of x is equal to 2 over 5x plus 4. So you could graph it and try to find it, but you can already tell it's going to be a fraction type. So the procedure to find an asymptote, right? So to find an asymptote. Oops. Okay. Set the denominator equal to 0 and solve for x. So you take the denominator, 5x plus 4, set equal to 0. Then you solve like you've always done. You factor 4 over, right? Divide by 5 on both sides. X is equal to negative 4 over 5. So this is the equation of the asymptote. Okay. Now if we graph the original and we graph this line, you'll see that center point that it can't cross. Okay. Let's go ahead and do that. So my g of x is equal to 2 over 5x plus 4. And the asymptote that we found was negative 4/5. So look at it closely. Right. This is the line. The x value it cannot cross. It is undefined at that value. X equals to negative 4/5. Okay. And that's what we solved for. Is what is this asymptote? Okay. Does that make more sense? Or?
So it's only where it crosses at y equals 0. Like,
One more time.
it's only when it crosses at y equals 0.
It's only when the denominator is equal to 0. So you need to find out what x value does that.
But so if we go like further up on the graph and it does eventually hit that x,
It doesn't ever.
and we can see that just in those first few.
They can keep zooming in forever. It gets infinitely close, but never actually touches.
Gotcha. Oh, because otherwise then it wouldn't be split into 2.
Yeah. Otherwise, it would be undefined because if it gets there, that means division by 0 happens, which is not supposed to happen.
Okay, gotcha.
And yeah, it would be connected too, like you said. Why would there be a gap if it's undefined? Okay, that is true. Okay. Let me give you, all right, here we go. Give the equation of the horizontal and vertical asymptote of this rational function. Okay. So for the vertical, right? We'll do the vertical stuff first. Set the bottom to 0 and solve it. So this will be vertical asymptote. Horizontal, you just check which case is it. It appears to be case 2. So y equals to 0 is the horizontal asymptote. These are the equations.
Can you explain the horizontal asymptote one more time? How did we get to case 2?
So case 2 is because, so you look at the degree, right? The degree of the top has no x. You see that? Right, it's just an 8. So that means it's degree 0 if there's no x up there. So degree of the denominator is bigger. Therefore, case 2. So down here it's 1, up top is 0. So that means n is less than m. So we have case 2.
Gotcha.
Okay. So any other questions on, we're going to do a couple more, but any more questions on the cases or this example? Do another one. Give the equation or equations of the vertical asymptote and vertical asymptote and horizontal. Okay. Of the rational function. So here it is, a random function. For the vertical, we look at the bottom, set it equal to 0, right? Solve for x. This is the equation of the vertical. I skipped a step there. For the horizontal, the degree of the denominator slash numerator is equal. Therefore, three dots means therefore in math books. Therefore, case one, y is equal to 5 over 4. You take the numbers, these guys here, and you divide them. And pretty much it for 3.6. If you have any questions on these asymptote ideas? Okay, please, I recommend that you graph them as soon as the question starts, that way you can see visually what they look like, and then start the problem. Okay? But sometimes a graph can give you the answer. All right, let's take a short break. It's almost 6 o'clock. Come back at 6:15. the law of exponents. So if n, m, a, and b are real numbers, with a being greater than 0 and b greater than 0, then the following is true. So a to the n times a to the m, you simply add the powers, right? If you already have a power and you raise it to another power, you multiply them. If you have two pieces or two factors and you would raise it to a power, well, they both get that same power. I'm just going to put a line here, that looks weird. Okay, so this will be 2 here. You have a fraction and you attach a power, well, both parts of the fraction get the power. If you divide, you subtract the powers, right? If you have a fraction with a negative power, you just flip the fraction and that power becomes positive. One to the s equals 1. A to the negative s is equal to, oh crap, I'm not using s's, I'm using n's. 1 to any power will always be 1. N to the negative, a to the negative n power means you make it into a fraction, you take the reciprocal, put the n down there. You can also leave it this way and put a positive n up here. And of course, a to the 0 is 1, except a cannot be 0. Doesn't work for that guy. So these are all our power properties, right? So they're going to be in the background. So the section assumes you remember that. So the new stuff. And if you forget something, you can always ask me. It's not a big deal. Definition. So an exponential function of the form f of x equals to a to the x, where a is a positive real number and a is not equal to 1. The domain of f is the set of all real numbers the domain of f is the set of all real numbers. Yeah, that's right. Just a quick note here. A is called the base. And x is the exponent. So that'll be 1, 2. All right. If we allow a to equal 0, we get f of x equal to 0 to the x, which is equal to 0. This would be the 0 function. So it's not interesting. That's why we prefer a to be something other than 0 and 1. Otherwise, it's not really an exponential. Same thing if it's a 1, right? If we allow a to equal 1, we get f of x equal to 1 to the x, which will always be 1 for all x's. This is just a constant function. And so not a exponential. Okay. The following are actual exponentials. So examples of exponential functions. So base 2, base 3. They can also be decimals. They can be fractions. Doesn't matter. It could be a decimal. But they look like this. So let's see. Equal to 2 to the x. This is your exponential function. So as you can see, it grows really quickly. I'm sure you've heard that term, right? Growing exponentially. This is what they mean. After like a couple of numbers or points, it really explodes, right? And it's only a power 2, so the higher this gets, the faster this spreads, right? Okay. Which can be, these types of models can also be applied to virus spread, right? After a few people are infected, this thing just starts to skyrocket. It gets really quick. Now, if it's equal to a negative x, it's going to be reflected. So this guy just shrinks or decays as x grows. So it has the opposite mirrored effect as the original. Although this negative power means, right, looking at our rule properties, that you can change this to a fraction, right? So this would be the same as saying yeah, there we go. 1/2 to the x is the same deal. You see that? So negative power just means you take the reciprocal of what's in here. Anyway, that's what they look like. This is the definition. And that's how they grow. Okay. So let's see, let's look at our what type of homework questions we're going to have. Okay. So like if they're talking about an investment type of model or equation, say like how much do I have at the beginning? You plug in times 0. It's just going to be x equal to 0 or t equal to 0, depending on what they use, right? 3 days later, well, they said that x is in days, so plug in 3. So that would be 8,800 times 2 to the 3. And of course, you can just use your calculator, it's whatever, right? I don't know what 8 times 8,800 is either. Let's see. It's going to be 70,400. Yeah, this section shouldn't be too bad. I think that's like one of the hardest type of question there is. The rest are just plug stuff in. What happens? What does this graph look like? So you graph it and you pick the right multiple choice. So I don't think we need to do those. You guys have any questions on exponential before we get to more detailed problems? Let me send you a PDF that has a few more examples just in case you forget. I want to focus more on the applications. These are more challenging. Okay, yeah. So 4.2 is the section is a little bit harder. You guys have any questions on 4.1? So it's going to be the same stuff on this section, except we're applying it to a lot of different word problems. Okay. All right, let's get to it then. So let me give you the notes that you need to understand what we use this for. Okay. Applications of exponential function. Okay. So we're going to have let me try to generalize both for decay and growth. So exponential growth or decay function. So under normal conditions, no, I don't like phrasing it that way. Sorry. Phrase it better. Sorry, sometimes I read the book and I realize they overcomplicate stuff. I'm trying my best to keep it more simple. F of x is equal to, well, they use t, so let's go ahead and do that. Some t's look a little weird. So there's t. Y naught times e to the k t. This is also called y0 or y sub 0, y naught, initial y. It's all the same thing. So this is the general form for exponential growth or decay. Okay? Or sometimes it looks like this. F of t equal to y naught times b times b to the t. Okay. So what does all this mean? Well, f of t represents the amount present at time t. So whatever we're talking about, is it bacteria, money, whatever? F of t means how much do I have at a certain time. So y0 is the amount present at time t equals 0, meaning the starting amount. Y0 is the starting amount. T is time. K and K and B are constants that depend on the rate of growth. So the K is actually going to tell you what kind of growth you have. So if, this is the first one here, if K is greater than 0, so if K is positive and B is positive, greater than 1 at least, then we have exponential growth. Number 2, if K is negative, if K is less than 0 and B is a fraction, and what I mean by that, B is between 0 and 1, but not in proper fraction. It's less than 1, bigger than 0. Then we have exponential decay. Okay. So this should help us start some of the questions. do the simple one first. Use total debt. The amount of debt across all sectors in billions of dollars can be spent I'm sorry, hold on. No. My mind wandered. I started thinking about spending money. So total debt in billions can be approximated. By the exponential function. So they're saying that this guy right here is modeling or is able to model the debt across all sectors, let's say in the country or something, or some city, who cares? 0.083 t, where t equal to 0 is 1970, and t is in years. Okay. So here it is. Data is from the Federal Reserve Bank in St. Louis. So that's where this model came from, but that doesn't really matter. Just a random fact. Part A. If the amount of total debt was 1946 billion, you can go ahead and put that somewhere else, some space there. 1946 billion. Find the amount in, let's say, 2017. Okay. So, before we start, we have an incomplete model, right? We don't know the initial amount. So, if you read this, do you see how much the initial amount is? Right? T equals to 0 corresponds to 1970. So the beginning, this model begins in 1970. It cannot tell you anything about before the 70s. So, right at the beginning, it says if the amount of total debt was 1946 billion, oh yeah, I messed that up, and I did not put the year. So this piece is what tells you the starting amount. Right here. In 1970. find the amount in 2017. So this one right here tells you what y naught will be. So you get the function started at 1946 times e to the 0.083t. Okay. So they're asking what happened in 2017. Well, how many years later is that? Right? Looks like 47. So 47 years later, what happened? So this is 0, then this will be 47. So what they're really asking is find f of 47. That's the actual question. You just have to kind of tease it out of there. So at this point, you use your calculator, plug in this number, 1946 times e to that number. Let's see what that is. And remember, e is just a number, so it's like pi. E is 2.718. Pi is 3.14. Who cares? So don't let the e bother you. It's just a special base. Right? So they want to know what is 1946 times e to the 0.083 times 47. This is the debt that they expect based on this model in 2017. So that will be a crap ton of money, 9233.35. But this is in billions. So this is how many billions of dollars, right, that they owe. So when you do these questions, you have to first figure out, okay, do I have the whole model? Usually this will be missing or the K will be missing. Also, the K tells you if it's growth. Since the K is positive, right, that means it's going to grow. So their debt is growing based on this model. The initial debt was this much. This is the new debt in 2017. At least that's what they expected when the model was made. Once you have the complete model, and if they ask you about how much do you have at a certain time, you just plug in that time. You just got to figure out what do they think of 0 and what is the year they're asking about. I'm not going to plug in 2017 in here. I'm going to plug in 47 years later. That's how they set it up. Okay. Is there any questions on this first example here, or so far?
Could you show again how you got E on the calculator?
Oh yeah, it should be on. It's on any calculator, any scientific. On this type, you just hit second, and the division symbol has an E on it. What type do you have?
I have the TI 36X Pro.
Oh, let me get that one out there. I have that up somewhere. 1 second.
I know it's a silly question, but I can't find it on here.
Oh, it's fine. It's okay. So on this one, it's right here. So you would hit 14 or 1946. There's like a bunch of buttons here. Let's see. Yeah, it looks like it should be that good, but how do I access it? Oh, okay. Oh, you just press it multiple times and it'll cycle through. So you just press this little button here. It says E box. There's a little empty power, and then you type in your number, so 0.083 times 47. That should be the same answer we got.
Yeah. Okay, great. No?
Okay, yeah, no problem. Let's do part B. Continue. Since we wrote so much for example 1, let's do another piece there. Okay. So assuming the model remains accurate, so if the model remains accurate, what will the total debt be in 2021? So you have your model already completed, right? 1946 e to the 0.083. So how many years later is 2021 from 1970? I don't know. So 070. So 51 years later is 2021. Right? Yeah. So just plug in 51. So the question they're asking is, what is f of 51? So 1946 e to the 0.083 times 51. So it looks like it will be approximately 134,125.50 billion. Okay, let's do another one. Does have any questions on example 1? Okay. Let's do another bacteria question. So suppose the number of bacteria in a culture at time t is y equal to 500 e to the 0.4 t. Yeah, we should stick with the function notation. So why not? The initial is 500, right? The initial bacteria, it's right there. K is equal to 0.4, which is greater than 0. Therefore, we have growth. Just by looking at it, you can tell all kinds of stuff. Also, an extra thing, T is in years. Forgot to write that. No, sorry, hours, not years. Hours. Bacteria growth. You'd probably be dead in 1 year, so it doesn't make sense. So that's all our info. Part A. How many bacteria are present initially? And to find this, you would just plug in 0 and solve for it, but kind of already know it's always going to be this number in front of the E or whatever, the B, depending. It's not always E. It could be a B, it could be a number 2, whatever. But the number in front, the coefficient, is the initial amount, y0. So what you're supposed to do is this, but you don't have to. So this will tell you how much initially t equals to 0. To 0. F of 0 would be 500 e to the 0, which is just 500 times 1. 500 is initially present before the timer starts, right? But we already knew that. Part B, how many bacteria are present after 10 hours? So when that happens, just plug in 10, right? If they're telling you how much, we know that means they want to know f of t. So plug in 10. So let t equal 10 and find f of 10, f of t. So here we go. That'll be 500 e to the 0.4 times 5, times 10. So that should be 500 e to the 0.4 times 10. So we have quite a bit because exponentials grow really fast. 27,299.08 bacteria. I know theoretically these functions go on forever, but in real life, eventually the growth will stop if the resources run out, right? So if the petri dish runs out of space or food, they will die out. Any questions for example 2? All right. Let's do a financial question then. Okay, one moment. Take another short break. I guess it's 8 o'clock. Come back about around 8:15. And we'll start a couple of more examples. They tell you in years, you need to convert to months, right? 1 year means 12 months. So that means B of 12. I just put a 12 in there and see where it goes, how low it goes. Okay. So that'll be 800.9898 to the, oops, 12. So now it's down to 707. About 707 and 39 cents. Okay. So far, is there any questions on these types of problems? If you were to continue this for 8 years, you would still owe about 300 bucks. So, which is the reason, as we said before, you need to always pay more than the minimum, because that interest is going to kill you. Like if you buy a house, let's say you get a 30-year loan. At the end of the 30 years, you would have paid more than double the value of your home, just in interest. So like if your house is worth 200 grand, 30 years later, you would have paid 400 and change, 450,000 or so, assuming about 3% rate. So interest is a big deal. Don't try to pay stuff off sooner if you can, or don't go into debt at all if you can help it. Anyway, let's see if there's any examples in the homework that are weird before we move on. Let's see here. Yeah, it's pretty similar to what we've done already. Yeah, that's about it. Yeah, so that's fine. Oh, this is a good one. Maybe. Okay, so there's a couple of questions where they don't give you the model, and you need to create the model. So those are a little harder. Let's do one of those. So all they give you is information, and you know the general models, so you need to find the initial amount, and you need to find the B or K, depending what kind of question. Okay. Okay, so the annual average price per square foot for office space in a city was $30 in 2004. And it was 67.04 excuse me, in 2015. Find the exponential model of this form. Why not times b to the t? Okay. Okay. So they're not giving us anything. You need to use that information to figure everything out. Okay. So they do have to tell you that t equals 0 means 2004. So that has to be given. Okay. So these are actually points, x and a y, or a t and a f of t. So really, we have at 2004, which is times 0, we had $30.44 for office space. And we had 2015, which is what, 11 years later, right? 116704. So we have 2 points. So time and a function of time. Time and the price at that time. Okay. So this is pretty much your starting amount, right? You can plug in 0 and solve it, but it should be clear that at time 0 I have this much. So why not is going to be 30.44 because that's the amount at t equals 0. So now we have f of t equal to 30.44 b to the t. So we just need to plug in the other point and solve for b. Okay. So now plug in 11, 67 and solve for b. So f of 11 is equal to 30.44 b to the 11, which is equal to 6704, right? Okay, so just solve for b. Divide that number over, right? Divide this number. So we get b to the 11 equal to whatever the heck that is, 67.04 divided by 30.44, 2.20. But I need to solve for b, not b to the 11. So what you can do is 11th root both sides, which sounds kind of weird, right? But you can. Just like we deal with square roots, you do a square root. You have an 11 power, use 11 roots. So b is equal to whatever this is, which is, what is this equal? Approximately this time. By the way, wave equals means approximate. So the way you do that, right? If your calculator does not have an 11th root, remember that roots also mean 2.20 to the 1 over 11, right? So you could use that instead. If your calculator, if you can't figure out how to use it, you can just use that. So I could say 2.2 to the 1 over 11. And put parentheses because that looks really weird. It's approximately 1.07. If I use the root 11 root of 2.2, it should be the same. See that? Right. So this would be, so now our model will be 30.44 times 1.07 to the t. So now it can tell me what the office space costs between 2004 and 2015 and possibly after 2015. So it can model future prices. You might have like one or two of these times, but most of them will just be like we did before, just plugging in numbers and seeing what happens.